All right, here's EOC review starting at number 28 and continuing on until I'm done with this section. All right, so here's a given triangle with these vertices. I'm going to brighten this up a little. Oh, that's the wrong button. That's as bright as it gets. Okay, so with these vertices, I've transcribed them in here, and the first transformation is a reflection across the y-axis. When a thing is reflected, the x's and the y's stay the same unless it's a reflection across the line x equals y or y equals negative x. And it's the y-axis, so the x is flopped. Okay, so I'm going to, the x changes sign. So the y's stay the same, so I'm just going to transcribe those. 1.7, why did I write y? This should be 4. This should be 4, and it should be negative 3. The 3's, the x's stay the same values, but they change values. So this will be 3, negative 2, and negative 0.4. Okay? And so going from there, we're going to take the next transformation, which is a translation of, where's my green, of negative 3 and plus 4 for the y. All right, so this means our x's we're going to subtract 0 or 3 from. All right, so this will become 0, negative 5, and this will become negative 3.4. And then these are going to be, add 4 to it, so this will become 8. This will become 5.7, and then this will become positive 1. Okay, so that is how you do that one. I made a math error here, hold on. So it's a 0 minus 0.4 minus 3 is actually 2.6. I made a minor math error there. So this is negative 2.6. Negative 2.6. Oops. All right, so moving on to this one here. All right, so here we have just one transformation. This is a rotation of this. All right, so this is a counterclockwise rotation. 90 degrees, the x and the y's just flop. If it's counterclockwise, the first term is changed. Right, so the x's and the y's flop. Let's do that first. This is negative y and x. So let's take the x's from here and put them in the y column. Okay, so it's going to be negative 1, 3, and 1. Then the y's go in this column. And it's 4, 4, and 7, but they also change from positive to negative. So these are going to be negative, negative, and negative. Okay, that's how that one was worked. Number 30 is a weighted average of these two numbers. All right, the first one is weighted as 1/4 of the first number, which is negative 1. So we're going to take negative 1, we're going to multiply it by 1/4. So negative 1 times 1/4 in decimal form is negative 0.25. And we're going to take the second number, and we're going to multiply it by 3/4 on the second number. So it's going to be 5 times 3/4, which is 5 times 3/4 equals this, and I'm going to turn out the fraction decimal, which is 3.75, and then I'm going to add those together. 3.75 minus 0.25 equals 3. 3.5 is the weighted average. That is how you do those two. Okay, so first number, second number. That's as simple as that. Moving on to this one, diagonal of a square. So first has these two vertices. Now the first vertice is 5 and negative 2. Second vertice is 2 and negative 6. Okay, so what is the length of that vertice? Let me draw that vertice, and what is the slope of that vertice? All right, first the slope of that vertice. That's ugly. Let's Make it bigger, make it a fat line, I guess. All right, so what is the slope of the vertex? We'll call this, I'm gonna call this AB. Right, so the slope of AB, the slope of AB, slope of AB equals positive, right? And it's going to go from the change in y is 1, 2, 3, 4. And the change in x is 1, 2, 3. It's 3. All right, so my slope is 3. Okay. How about the change is 4 and 3, right? So the midpoint for my y value, so my y and my x value, 4 divided by 2 is 2, right? And 4 divided by, and 3 divided by 2 is 1.5. 1.5. So it's going to be the difference between those two. This is going to be 1.5 from here. So it's going to be 1.5 from there, and then 2 up. So this is my midpoint. Okay. All right, so that's my midpoint, and it's 1.5. This is my A plus 1.5, and this is my A plus 2, my A plus 2 in my y direction. Okay, so that's how I do that. All right. So now I need to figure out what my points are, and I know that these are going to be, my diagonals are perpendicular. All right, so perpendicular, meaning that the slopes are going to be opposite, and the opposite and inverse sign. All right, so that slope is going to be, we're going to call my other lines CD. CD, my slope of CD is going to be -3/4. Right, so from this point here, it's going to be -3 and 4. Right, so it's going to be -3/4 one way and -3/4 the other way, but it's not going to be as far, right? So, but I know it's going to intersect this point, which, by the way, this point, by the way, is, let's see, it's 3.5 and -4. Okay, so that's my slope. So, so I know that it's going to go 1.5 this way, and then it's going to go 2 down. No, it's going to go 2 this way and 1.5 down, because the slope is going to be different. It's going to be the opposite and the negative, right? Because it got, in order to get the slope of 4/3, it went 2 up, right, and then 3 over, right? So our change is half of that, right? Because we're looking at the midpoint. Okay, so we're looking at, to go from the midpoint here, right? We're going to take half the slope, right? Because we're half the way to find our midpoints here, we're going to take half the slope and go from there, right? Or we could just go from here and do our slope from here, but I think we would just get, maybe not. Let's look. So if we go -3, so we're going to go 3. Well, from here we have to go -3, 1, 2, 3, and then go 4, 1, 2, 3, 4. So that is one of the points, I believe. And then from here we are going to go 1, 2, 3, and then 1, 2, 3, 4. So that doesn't look right. No, that doesn't make sense. So that was a slope of 4/3, 3/4. So I think we need to go from here. We need to go from here and do a slope. From here we need to do a slope of -3, of 4, of 3 and 1, 2. No, it doesn't work either. All right. So from here we need to do the half. So we need to do half of our slope. From here we need to do divided by 2, because we need to go from our center point. So we need to do -1/2 half over 2, and we need to do negative 2. We need to do negative, we need to do 1/2 over negative 2, right? Because that's really all we really have to go with from this reference. Okay, so let's do this one to find C and D. All right, so let's do negative 1/2 down, negative 1 and 1/2, and then 2, 1, 2. So that's that one, I think. So negative 1. Oh no, I did that wrong. I did 2.5. So negative 1 and 1/2, and then 2 puts me right here. Okay, so that would be, let me call that D, I guess. And then for this one, it's going to be 1/2, 1 and 1/2, 1, 1 and 1/2, and then negative 2, negative 1, negative 2 puts me there. Okay, so that is a perpendicular line with the slope is half of this one, right? So if I go, so this point here is 1/2, 1.5, and 2.5. 1.5, 1 and 1.5, comma, negative 2.5. And this point is 5.5, comma, negative 5.5. Okay. So what is the slope? All right. So the slope should end up being, so the change in x, the change in y over the change in x. No, it's going to be negative. So my change in y is 5.5 negative minus 2.5 negative equals negative 3, and then 5.5 minus 1.5 equals 4. Yep, and that is my slope. So that is correct. That is my correct line. And then connecting, this is A, this would be C, and this is my square. It's not as obvious as one may believe. That is my square. Okay? And that was a little awkward, huh? Okay, so I just proved it over here that the two are perpendicular. Okay. So anyway, all right. So here we go. We have two lines, or 2 points on a line, and it is from, let's say, right here to here. No, I want to go from here to here for a specific reason, right? And this is M, and this is N, and this is negative 4, comma 7, and this is 12, comma negative 2, right? So it and if this is a P partitions it at a 2 to 3 ratio. So that means this thing is split into 5 sections, because 2 plus 3 is 5. So there's 1, there's 2, there's 3, there's 4, and 5. Okay, so that's 5 sections evenly. Okay, so what is the change in x and the change in y going to be? This represents my change in y, and this represents my change in x. Change in x. Okay. It was a little uppy downy, but that's all right. That bothered me. I can't do that. I can't do that. That bothers me too much. So this is my change in x. Alright, that's more acceptable. Alright, so my change in x and my change in y. So my change in y, it's a negative slope, and it goes from 7 to negative 2, so that is a change in 9. So my slope is, my numerator is 9, and my change in x, oh, that's 9, that's fine. I don't need to really know the slope. My change in y is 9, okay? Absolute value is 9, okay? And then my change in x goes from 4 to 12, so my absolute value is 16. Okay, so I know that this has to be partitioned in a 2 to 3 ratio, meaning that 2 sides is on the m side and 3 sides is on the n side. So an easy way to remember this is that, say this is the left and this is the right side of the ratio. The thing that you have to multiply, we'll call this your multiplier, your ratio we'll call this the partition multiplier. Yeah, the partition multiplier, or the PM. Yeah, this equals your left ratio divided by your left plus your right ratio. So here it's going to be equal to 2 divided by 2 plus 3, which equals 2/5. So now I got to figure out for my x value. My x value is going to be 2, or equal to 9 times 2/5. Times 2/5. So 2/5 of 9 is like, so 9 times 2 divided by 5 equals 3 3/5. So, man, what's that in, like, that's like 3.6. All right, so this is negative 2. That's probably like, let's see, that means like 3.6, and this is 7, maybe like here, because 0 would be like here, ish, okay? And then 16 times 2/5, 16 times 2/5 times 2/5, so 16 times 2 divided by 5 equals 6.4. So this is negative 4. This is 12. That'd be like here, I guess. So this would be my partition of 9, or my partition number would be 2/5, and this point would be my 6.4, right? And what was this again? This was, whatever, I should have wrote it down, but I didn't. 9 times 2 equals divided by 4 equals 4.5. Was it? No, it wasn't. 9 times 2 equals divided by 5 equals 3.6. This was 3.6. So my point coordinates was 6.4 and 3.6. So this coordinate point is my 2, 1, 2, 1, 2, 3. A ratio of 2 to 3. I want to revise that last one. I made an error. Right, so the 3.6, I'm sorry about that, is what you want to start. This is your y value, right, and this is your starting point. So you're starting your 7, right, and you're moving downward. So you're going to take your 7 and you're going to subtract 3.6 from it. 3.6, right? So you take that, take your 7, and you subtract 3.6, and you get 3.4. So this on this here is 3.4. So same thing with your x value. You start at negative 4. You start at -4, and you're starting going this way, and you add your 6.4, which is your change. All right, so it's 4, or -4, plus 6.4, and then you're at, so your final value is 2.4. 2.4. And that, I'm sorry to say, had a conception error there. That is your 2/3 down the way, which makes more sense. So that is 2 and 3.4. So this number here, when you multiply your change by your partitioning multiplier, is how much you have to add to your starting point, right? Or subtract, depending on your trend, your sloping trend, right? So make sure you're paying attention to which way your trend is going, okay? So sorry about that. Part of confusion there, that's my mistake. All right, so here we go. We have a triangle. This is a triangle located ABC. We'll call this A, we'll call this B, and then we'll call this the centroid. Call it Troy, T for Troid. Okay, and the troid is located at -1 1/3, and it'll be green. And then A is at -4 and -1. A, and B is at 3 and -3, and that is at B. So 3 and -3. And what's the vertex? And what's the third vertex? So what is C? So what is C? All right, so we know that this is simply the average of the 3 points. So we need to figure out our C value. So what we got here is our C value for X, and our C value for Y is simply, we got 3 values to get those, right? So that's this is the average part. This is the average of our X values. This is the average of our Y values. Okay? And now this is one of the things we added to get our X value. And so is that. And this is one of the things we added to get our Y values. -1, and so is that. All right, so we've plugged everything in, and now let's math a little bit to solve what we need. All right, so multiply both sides by, we'll do this one first. All right, so we're going to multiply both sides by 3 to get rid of the fraction. So that's going to yield -3 equals -4 plus 3 plus our X value for C. I can move that up. I can move that one side up a little bit so it's not as confusing. Equals -3 equals negative. Wrong side. Equals negative. I did it again. Equals -3 equals that. All right, so that is how that changes. Okay, so I'm gonna rearrange some stuff here. So 4 negative plus 3 equals -1. I'll move that to this side, making C 4. So I'm going to add that. So C is going to equal to 2, I believe. So 4 negative plus 3 equals -1. That's going to be -4. So 4 negative equals X. Right? So I believe so. C. So I mean, I'm getting tired. I need to. All right, I'm just going to write it out. I'm going to just write it out. So negative. Do it in 2 steps. Man. -3 equals -1 plus CX. So that's going to go over there, become positive. So -2 equals C. Man, that was so hard. Why was that so hard? So I'll do this over here. I'll just do this over here, give me room. Therefore, negative 2x equals, negative 2 equals cx. Holy cow, what is going on in my brain? Equals cx. Oh, algebra, gross. All right, so anyway, so then we have this thing, when 3's cancel out, or not they cancel out, but they multiply both sides by 3, and you get 1 equals negative 1 minus 3 plus cy. The plus a negative is a negative, okay? So this is going to be equal to 1 equals negative 4 plus cy, therefore c negative 5 equals cy. No, that's not right. Holy cow. 4, oh wait, 5 equals cy. I bring it over there, equals cy. Gotta add 4 to both sides. So our point value for cy is negative 2 comma 5. Boy, oh boy, why is that so hard? Anyway, all right, so negative 2, my x, and 5 is my y. All right, that looks like it could be the centroid. That makes a lot of sense. All right, let's go ahead and put that here. This, put this here, like this. Put this here, like this. And if it truly is a centroid, each one of these should pretty much bisect each line. Each of its opposite lines, which it looks like it does pretty well. Yeah, that's, oh, you can't even see what I'm doing. There we go. So that looks like it's pretty much the centroid. And classify what type of triangle this is. It doesn't look like it's anything special. This line segment length is, let's see, 1 and 7. So 1, that's 40, that's a square root of, this line segment length is the square root of 50. I think 7 squared is 7 squared. Yeah, that's a square root of 50. That's a square root of 50. This one is, let's see, 2, and how long is this guy? 2 and 2 and 7, 6. So 2 squared plus 6 squared equals 2 squared plus 6 squared equals 4. That's the square root of 40. That's the square root of 40, so nothing special there so far. And this guy, this looks like this guy here is a, let's see, it goes from, change of y is 5 to negative 2, so that's a 7 change. And from x, it's a negative 2 to a 3, so it's a 5 change. So that guy is a 7 squared plus 5 squared equals that, and take the square root of that. That's the square root of 74. It's the square root of 74. Yeah, I don't think that's anything special. I think it's a scaling triangle. So let me pause and take a look at that real quick. Yep, the verdict is in. It's nothing special about the triangle. It's a scaling triangle. So that's that one. Let's see if I got anything more in me. So this is 33 and 34. All right. So we have a community garden. It's starting the first corner, working counterclockwise. The second corner is 200 feet east. Okay, so this guy here goes from here to 200 feet east. East is that way. Right, so, because this is, oh, I dropped the pen. North is this way. North, west. Oops. This is east. And that means this is south. So, south. So east is this way. We're starting at the first corner and working clockwise. There's 4 corners, and it goes 200 east. So each block of these is 20. Oh, it's right here. Okay. So 200 east. So from here to here, it goes from here all the way to here. Can you see? Oh, you can't see that. It's kind of overlap it a little bit. Can't see that either. Marker. So from here to here. Yeah, that you can see. All right, so from there to there is my first one. Okay, then the second one is third corner is 150 foot north. So we gotta go from here to like 150 is like there, I guess. Yeah, it's like 150 foot north is like that. Okay, and then it goes back 100 foot west. 100 foot west is like like to there. Oh, no, up to there. So it's like from here to here, 100 foot west, that way. And then it goes back to the initial part. It goes back this way, I think. That's the second corner, fourth corner, and the west. Yeah, I think that's it. Right, so that's the way this thing looks. That is the perimeter of this garden. Determine how much fence is needed. So what's the perimeter? Well, look at this. We have a triangle. And so it's asking for the perimeter, and it's asking for the area. Oh man, this one's a toughie. Not really. All right. So we have from here to here, from here to here. What is the distance between here and here? Well, between here and here is 150. This is 150. From here and here is 100. And from here and here is 100. And from here and here is 150. What is the length of this? Well, this is the square root of 100 squared plus 150 squared because Pythagorean's theorem. All right, so 100 squared plus 150 squared equals square root is approximately 180.3. Equals 180.3. These are all feet, all units in feet. All units in feet or feet squared. Okay. All right, so what is this? So this is 100. Okay, so this is 200. 200. So 200 plus 150 plus 100 plus 180. The perimeter equals 630 feet. And that's the perimeter. All right. Excuse me. Then the area. This is going to be this area here is going to be 100 times 150, which is 15,000 or 150,000. 15,000. 15,000 feet squared. And this is going to be 15,000 feet squared divided by 2. Because it's the same width, the same height, but it's only 7,500. We're going to add them together. grand total is 22.5 foot squared. So that is how you do that one. Super simple. All right, plus this equals that. So super duper easy. I think I'm spent for the day. Going on to number 35 tomorrow.